So here's kind of a quick overview of some of the things that we're going to cover in this training. We're going to talk about, NLign is basically a 3D database. One of the first things we're going to talk about is how NLign stores data, kind of the structure of NLign, how it's set up, how data gets stored into NLign. We're going to talk about the model view, which is what you see on the left-hand side of the screen here. It's similar to a CAD package where you can rotate and view different things on the model. We'll talk about trendables, and trendables are just different data records. How you can filter through the data, how you can see results of the different records or trendables, how you can create records or trendables in the system. We'll talk about damage mapping, which is placing a photograph on top of the CAD model so you can get exact location information just off of the photograph. We'll talk about some of the different color presets you can use to quickly highlight areas where specific data points on the model and quickly see some, using colors, you can see some patterns in the data. We'll talk about clustering, which basically is a defect concentration diagrams, finding where some of your hotspots on the aircraft are, where you're getting the most records. We'll talk about how to set up some charts. We'll talk about workspaces. We'll talk about pulling in legacy data via CSV. We'll talk about named regions. So that's kind of a very quick overview of what we plan to cover throughout the 6-week course. And we've got several example problems. So I'm glad to hear that you guys downloaded NLign. So we're going to go through and do some of these examples. And as we do them, please follow along in your software. Okay, so some basic terminology before we start. We're going to be talking about models or model files. So a model is basically any CAD file, a finite element file, a shell model. Those could be, from CATIA, JT, IGES, or step files. BDF files from a FEM package like Nastran, Patran, Abacus, things like that. And then an asset displays the specific models and or records, and it's in charge of the different security rights to the data that's stored onto that asset. So assets can have multiple models, and you can kind of think of the multiple models within an asset like layers within Google Maps or in Photoshop. You can turn on and off those different layers to get different pieces of information about a specific part or aircraft. Another way to think about assets is, all the records are stored within a certain asset. So some of our customers divide up their database into different assets that contain the model in one asset, and then maybe the maintenance data in another asset. Maybe they have repair data in a separate asset. And so assets are just different ways you can divide up your data. And so depending on your specific program or your specific needs, whoever the administrator for NLign is may have set up the assets in a different way. And that's something that you'll want to talk to whoever your admin is as far as understanding how that setup has been done. So, whoops. Another couple of terms is trendable. A trendable, anytime you hear me say trendable, it's basically a data record. And so a trendable is basically all the information you need to describe a certain piece of information. So if we use like a paper-based analogy, a trendable is just a filled out form. So, if you've got some inspection form that you fill out as you go to a part to record the discrepancy or non-conformance, the trendable would be that piece of paper that's filled out with all the data. Now, the trendable type is, kind of back to the paper analogy, is that piece of paper without any data on it. It's the template, it's the copy that you take out to the shop floor to write the data into. So a trendable type basically determines what information needs to be captured. So there could be one trendable type for inspections. There could be another for discrepancies. There could be another trainable type that records information about the configuration of the aircraft. Um, there's multiple different things that you can create for the trainable type that you could record data off of. Okay, so this is a really nice slide for future reference. I'm just going to point out a couple of things. Don't feel too bad if you don't understand everything on here. That's fine. Basically, within NLign, there are two places where data is stored. There's data that's stored on top of the asset or within the asset, and those are the models, the individual trendables, named regions, stored views, and asset folders. Now, the trendable types are asset independent. So, earlier we talked about trendable types. You could have an inspection form, and so that could be one trendable type, or we could have a trendable type called crack. And a crack could happen across multiple different aircraft, could happen across multiple different systems. And so the trendable type of crack would just list all the things that need to be recorded when you find a crack. What's the length of the crack, the direction of the crack, what hole was the crack found on, and so on and so forth. Once you fill in that piece of information, it becomes a trendable or a data record, and it lives on top of a specific asset. It lives on top of a certain aircraft, a certain system, and then so the specific data is stored within the asset. But the templates, the blank forms are asset independent. Okay, so we've talked a lot about assets. Where do we actually find assets? So if you go to in your NLign instance, when you go to the File, select Asset, it will give you a list of all the different assets that are available for you in your system. So this is just some examples of some of the different assets that you could have. So you could have nonconformance data asset, and then you could have a trendable type of the nonconformance 107, 202s, EWA production. You could have an ASIP trendable type, and your support analysis lives on that asset. So like I mentioned earlier, there's multiple configurations that you could have. And so for your specific configuration, I would talk to whoever your admin is to get some type of a chart like this that diagrams out where the data is stored. Okay, now let's really jump into the software now. Here's our first example problem. So you've got NLign installed, and your boss comes to you and says, hey, I a presentation that shows a cross-sectional view of the aircraft with a view of all the records displayed onto that aircraft. So the first thing we need to do is make sure we have an asset loaded. We need to run basically a blank filter to pull in all the records onto the 3D CAD model. And we need to orient the model to the desired orientation. We need to turn on a clipping plane and then basically snap the picture. Those are the steps we're going to take to work through this example together. Go ahead and maximize my screen here. Okay, so like I mentioned, where you find the assets, you go File, select Assets. If you've loaded NLign before, it remembers which asset you had previously loaded, and that will be the default. If not, if this is your first time loading it, it will prompt you, which asset you want loaded. If you have multiple assets, this is where you pick between them. You go File, select Assets, and you load your asset. And then the very next thing we're going to do is load a default data set. So the default data set is typically blank. Unless you've gone in and played around in here previously, there shouldn't be anything inside this default data set. So the default data set is basically a blank filter. It takes everything in the database or on the server and pulls it straight to your screen. So on my view window here, in the upper left-hand corner, I have this little play button right next to this drop down that says default data set. So if I run the default data set, it pulls in all the records that are in my database. There I can see all these little kind of red and yellow circled dots are the different records that are in my database. So once I've got the data onto my model, I can use my mouse to control the model. So if you've ever used a CAD package previously, some of these controls will be very familiar to you. So you can click and pan, you can right click and start rotating when you right click and then drag. To set the center of rotation, you click on the model with a right mouse click. To zoom, you use the scroll wheel. And then to select a part or item on the model, you just click on it. You can toggle the visibility of the part with the H key on your keyboard or in the layers tree with the eyeball icon. So I can rotate, I can zoom with the scroll wheel, I can pan by left clicking and dragging. I can also select different parts. So as I click on the part, you may notice it highlights in the parts tree what that part number is, and vice versa. If I click over here in the parts tree, it will highlight the part over in my view window. If I right click and drag, it will rotate. And if I just right click once, it should reset my center of rotation. Another way I can reset my center of rotation is clicking up on the gear icon. And I can set the center of rotation to a specific point. And I just click on my model. And now I'm rotating about the front nose of the aircraft. So if I'm working at the forward end of the aircraft, it just makes things easier for me if I can rotate about there instead of rotating about the center. I can reset the center of rotation back to the center of the model. And then as I talked about, I can zoom in and out with the scroll wheel here. Let's see, I just saw a chat up here. Can I select multiple parts using control click in the model window or only in the layers tab? Great question. You cannot select multiple parts as far as I'm aware in the view window. You can only do that in the layers. So if I click on a part number and then hit control, I can select multiple parts. These are actually just nut plates down here, so they're not super large. I'm just going to get something a little more substantial here. There we go. I can hit control and select multiple things, or if I've got multiple parts in a row, I can hold the shift button and then select all those parts at once. So if your admin loaded in the models from in kind of an organized fashion from a CAD package, you should have some type of a layers tree that's similar to this, where you can find the assemblies highlighted in here. Okay, so I need this picture for my presentation. I've got the results displayed on top of my model. Now I need to create a cross section. So if I come up to the gear icon and click on manually edit the clipping planes, what this does is it allows me to, there we go. Sorry, it was on another screen. It allows me to turn off the automatic clipping and then manually adjust the clipping plane here. I'm going to click and drag this. You can see the wing starting to disappear, starting to be cross-sectioned or cut off. I'll adjust this until it sits where I want it like that. So I can adjust the far clipping plane as well if for some reason I want to clip the far end of the aircraft. But for now, I'm just going to adjust the near clipping plane. Going to hit OK. And then there's several ways that I can basically use this picture for my presentation. I can click on this icon up here, and this icon is used throughout NLign, this blue piece of paper with the orange arrow to the right, to export things. Whenever I see this icon, it's typically going to help me grab things out of NLign. So I can either save this view to an image file, or I can copy it to the clipboard. So if I save this as an image file, it will just bring up the save window for Windows. I can give it a name, cross-sectional view. Go ahead and save that right here. There we go. So now I've got the picture ready for my presentation. One thing to keep in mind with the cross-section is this cross-section is not fixed in space. It is with reference to the camera view angle. So as I rotate the aircraft, my cross-section will also rotate. So keep that in mind when you're working with the aircraft. So as I zoom in and out, the clipping plane will also adjust based off of my camera angle. So another thing I can do if I don't want a solid part is similar to other CAD packages, I can play with the visibility of the different parts on the model. So as I click on the different parts, I can make them transparent. I'm actually going to turn off my clipping plane here. Put it back to automatic. I can change parts to wireframe. And I can also hide parts. And there's basically 3 separate ways I can do this. I can toggle the visibility of the part with the H key on my keyboard. And you may notice this eyeball icon turns to eyelashes. When I do that, I can click on this eyeball or the eyelash icon, and that will also toggle the visibility of that part on and off. Or I can hit on the hide all models icon up at the top. Now that will hide absolutely everything. But if I click on the top level and then display the models as a solid, it'll bring everything back again. Another feature that I have access to is as I click on the individual models, I have options to change the model color over here on the left. So I can pick a specific color and kind of draw the eye to that specific part. So if I'm, from this example in the presentation, if I'm trying to highlight a part that has a lot of defects on it, I could change its color to something that pops out a little more to draw the attention to that specific part in my presentation. Let's say someone from the shop floor comes to you and asks, hey, I'm looking for this specific part number. I was just assigned to go find it or work on it, and I'm not sure what it looks like. So one of the features that NLign has is a filter for specific parts. So if I know the specific part number that I need to find, I think in this example, they give us a part number. Yeah, this one right here. So let's say he gives me this part number. I can go up in the top of this. If at the far left, there's these different tabs. So I've been working in the layers tab a lot, talking about the part tree. As I click on the parts, the layers tab is where it displays the part number that I just clicked on. So if I have a specific part number, I can start typing it into here. And you can see off to the right, I've got this button that says one match. So this will, when I click on the exact match, it will jump to the spot in the tree and highlight it. as well as highlighting it in the model where it is. So I can also use portions of a part number. Let's see if, and I type in CFG and there's two individual matches. So to cycle through those two individual matches, I can click the up and down arrows here and find what they are. So if the part's obscured like this, I can see that the wing's in the way. I'm not sure exactly what or where that is. One of the tools that NLign has for finding that specific part is when you right click on a part or an assembly, you have the option to go to that specific part. And when I click go to that part for that assembly, what it does is it zooms in and hides any of the parts that are obscuring that part or assembly. So right here I can see, oh, this is the landing gear assembly. And this part was one of the main brackets for the two landing gear legs that are attached to. So, then I can show this to the, whoever came to me, the mechanic, the inspector, and say, hey, this is what your part is. And then he can see what the part looks like and go and find it, start working on it. So in the Layers tab, there's several different icons. You'll see asset folders, you'll see the models, you'll see stored views and named regions. So we've talked a bit about the different model files or the parts in the assemblies, similar to in a CAD package. The stored views, what they are is they are pre-saved views of the aircraft. So these views take into account the color of the parts, the visibility of the parts, the orientation of the camera, the section plane, like we just talked about. And if I click on one of these stored views on the lightning bolt, it will zoom in to the specific location on the aircraft that this view was created for. So in this particular instance, this is the air intake fastener view. And so here's my air intake for my engine. And here's all the different fasteners around my air intake access plate. So I've also got an isometric view. If I click on that, I zoom into, I zoom and scale through the isometric view. I can also have stored views that only adjust the visibility of the part. So if I click on this transparent view, it'll change all the parts to transparent, but it won't change my camera orientation. So if, for example, I was looking at one of the landing gears, and then I clicked on the transparent view, it wouldn't change the orientation of my camera. This particular view only saved the visibility of the parts. So to create one of these views, if I'm working, let's say I'm an engineer, I'm always working on this left-hand landing gear. One of the things I can do is zoom into the area where I'm working frequently. I actually just pick some other spot because we already have a landing gear view. Maybe I work at the forward end of the aircraft here on this skin. I can zoom into this. If I want this particular part to be transparent, I can change that. We've got kind of a profile view of the forward end of the aircraft. So I set up the orientation of the model how I want it, the coloring of my parts. And then in the upper right-hand corner, I've got some glasses with a plus icon. When I click this, it will create a new stored view using the current configuration that's in my view window. So as I click on this, I've got several options. And the first option it gives me is a specific name for this view. So I could call this something like forward end of the aircraft. skins transparent, something like that. Or I could just call it, forward end, and then I can add this to the description if I want. So I could snap to a different view, and then if I click on my forward end of my aircraft, I zoom back into the forward end, and my skins are transparent again. So you can see that these stored views can be really helpful if you're working in a specific area of the aircraft frequently. Maybe you're assigned to this forward end, the electronics, the radome, the antenna, things like that. And you're in charge of that area for nonconformances and data about that. It can be really nice to have something like this set up where you can quickly and easily snap to the area that you frequently work in. So now we've got an edge distance example. So let's say you've been assigned a new nonconformance. You need to gather some information about potential stress interactions. So within NLign, there's a measurement tool. So we need to grab the measurement tool and measure the distance from the edge of the corrosion to the nearest internal rib and to the nearest edge of the skin. So if you have the UAV environment, go ahead and grab this NLign ID 20599, and we'll go ahead and you can follow along in this example. So the first thing we're going to do is turn on the annotation view. We're going to navigate to the specific nonconformance. We're going to toggle on the transparency of the skin so we can see the ribs on the inside. And then we're going to use the measurement tool to get edge distance measurements from the edge of the corrosion to the rib. So I'm going to grab this NLign ID 20599. And then I'm going to go to my Datasets tab, open up my default dataset, and I'm going to click and drag this ID field into my filter criteria. I'm going to paste or type in my record ID number, 20599. Hit OK. And I'm going to run it. Okay, so here's this record. So I've already turned the skin transparent. You can see that it's within some distance of this rib, but this point actually only represents the center of the defect of the corrosion. So what I need to do is I need to turn on the annotations view. What the annotations view is it's the drawing of the extent of the boundary of the defects for the crack orientation. So if I go up here to the display settings icon, it's 4 bars with an orange dot to the side. And right now I have show trendable points toggled on, and that's what this point is right here. It's the trendable or the record center point. And what I want to do is I want to turn on show trendable annotations. So as I turn this on, I get an outline of where this corrosion actually, the boundary where this corrosion actually is. So you can see the boundary of the corrosion comes much closer to this rib than the center point of the defect did. So now that I've got this boundary turned on for the specific record, what I want to do is I want to come up here to the upper right and grab this ruler icon to start measuring the distance between the corrosion and the nearest rib. So I go ahead and click the measurement tool, zoom in here a little bit, and then I'll click on the edge of the corrosion. I'll hold in my mouse, and then I'll drag to where I see this rib starting. And then NLign will calculate both the surface and the linear distance between the 2 points that I selected. And it displays here the XYZ points that I selected for my measurement. So I can see I've got 1.7 inches between the edge of my corrosion and the nearest rib. So, if I'm a stress engineer, I could input that into some of my calculations, make sure my edge distance is sufficient. or if I need to calculate to the center of the rib for distance to a fastener, I could start doing that. Start doing my calculations to see if the part's still good. One thing to keep in mind as far as surface distance is if I go over complex curvature, or if I go between two parts, this surface distance is going to be much longer than the linear distance. So just keep that in mind as you're taking measurements with this measurement tool. One other caveat with this measurement tool is it's only as accurate as your hand and mouse are. So if you need a very accurate measurement tool, I would suggest, if you need it down to, to the 10,000ths or, to the thousandths decimal spot of accuracy, I would recommend going to a CAD package instead of using NLign to take your measurement. Because, if I do this again, I got 1.7 that time. If kind of floating around and I just do a quick little thing here, now I get 1.9, right? So depending on how steady my hand is, how zoomed in I am, it's really dependent on how steady you are with your mouse and how careful you are in taking this measurement. So it's great for kind of order of magnitude calculations, things like that. But if you need something down to the 10,000ths, I would definitely go to a CAD package. And there are ways that I can show you later for exporting the boundary of this damage into a CAD package. So not all records will have boundaries on them. If I clear out my default data set here, I can see that not every record has a boundary drawn for the extent of the damage. So that's something to keep in mind as well, that your database is only as good as the people who are inputting the information and drawing these boundaries on it. So if someone forgot to draw the extent of the corrosion or the direction of the crack, that information may or may not be in the database here. But this is one way you can see that. One of the reasons we allow you to toggle the annotations on and off is because let's say there's an area like this bracket right here. It's got a lot of cracks, a lot of corrosion records recorded on it. It can start to get really messy. So that's why we've got the option to, you can turn on and off the annotations or the points independently. So if I just want to see the annotations, I can turn off the record points, and vice versa. I can just turn on the trendable center points of the defect.
I had a quick question, Eugene.
Sure, please.
The annotations, has there been a way yet to kind of direct an address to annotations so that if you're exporting, say, a bulk export of data, is there a way to identify a location with those annotations?
I'm not quite sure I understand your question. You're trying to get an XYZ?
Yeah, so like with the points, you have a clear XYZ, and when you're exporting, you can actually see where it is. Is there any way to tie a annotation data record to a specific, not necessarily a specific location, but some kind of address to give context in your export of where that annotation is located at? Or would that just have to be covered in an additional field?
So let me quickly show you what you can do in an export. So if I click this specific example we were just using, and I apologize for those who are new, but to answer his question, I'm going to race through a few of these steps. So I go to export. One of the things I want to do here in my export of this data, I'm just going to export this specific trendable, but the concept is the same if I had multiple. I want to export the annotations, right? So I want to make sure this is highlighted in my export. Yeah, that's fine. And then once I navigate to my folder location, give me a second here. For example, so I've got my record, and then at the very end of my data record in my export, I'm going to have this annotations column. So it will say annotations /246 IGES. So in the folder where this was saved, I've got this folder called annotations. And so if I open up this folder, I should navigate to, I've done several exports, so that's why I've got several files in here. But if this was the first one that I had exported, I would just see IGES 246. So if I load this IGES file into a CAD package, it is, and I've also got the model. I will basically see this exact same thing right here. I will see, you know, this outline drawn on top of my CAD model. So what that allows me to do is I've got that on my CAD model, and then for my XYZ, here's that center point of that drawing, right, of that annotation. So that's where that point is right there, is this XYZ on the export.
So it gives the center point of the annotation.
Yes.
Okay, cool. Thank you.
Sure. And when we go over, probably in next class, next week or the week after, I forget exactly when, but we'll go over entering in annotations and making sure they have center points that correspond to kind of the center of gravity or the center of mass of what you drew. And that will give you your accurate XYZ location.